This is on. Okay. Hey, everybody. Thanks for joining me for what is probably going to be my silliest talk of the year. Let's just get one thing out of the way. How many people who know who Phil Collins is by show of hands? All right, we're going to have a lot of fun. For those of you who do not know who Phil is, I've got plenty of background information on him, and he's, yeah, we'll get to that part. So this talk is called Pseudio, and it will cover pseudonymization techniques in Django. Hi, I'm Frank. I'm FMD Frank on Twitter, but I am also on quite the extended Twitter sabbatical. You're welcome to go look at my greatest hits. They are there for you to peruse, but I may not go back. I don't know if I will ever return to the Twitter sphere. I work at a company called Cuddlesoft. We have offices in Denver, Atlanta, and Tallahassee, Florida. And I'm an avid Pythonista. I've been using Python as my primary programming language for the better part of 8 years. This is my first time at DjangoCon, and I'm very excited to be here. I'm also the co-founder and chair of Pi Colorado. We'll be having our inaugural conference next year in August. I'm happy to talk to anybody more about that if you're interested. Please come visit me in Denver. It's beautiful. And then I also run Boulder Python in Colorado. So yeah, thanks for having me. So my speaker in spirit is Phillip. Oh my God, I forgot his name. Phillip, sorry, it's right here. Phillip David Charles Collins. He's an English musician, and he's a drummer, singer, songwriter, multi-instrumentalist, record producer, and an actor. He was the drummer and singer of a rock band known as Genesis. And during the 80s, Collins had more US top 40 singles than any other artist, which if you're old enough like me to remember the 80s, that's actually quite impressive. He co-wrote a lot of the music on Disney's Tarzan. For the younger folks in the crowd, that will be probably how you know him. And I just learned that Peter Gabriel, none of this is relevant to the talk. You probably figured it out, but Peter Gabriel was the original lead singer of Genesis, and Phil took over for him. So why is Phil my co-speaker in spirit? Well, pseudonymization is an incredibly difficult word to say. Try it. How many of you got it right? Yeah, so Pseudio is close enough, and that was enough reason for me, as of any, to do a Phil Collins-inspired data privacy talk. Also, I'm pretty confident I'm the only one who have ever attempted this, so we'll see how it goes. All right, so if you've never heard of Phil, that's okay. I got you. We've got a Spotify playlist of some of Phil's greatest hits. He is on Twitter. He's Phil Collins' feed if you're interested. It starts with Pseudio, which is the song I started this talk off with. It gets kind of sappy towards the middle, like this talk will. I don't know, are there any tissues? If there are, you'll need them. This is heavy stuff, y'all. And of course, this playlist ends with the air drumming spectacular In the Air Tonight. So please check it out, enjoy it. All right, so let's get to the meat and potatoes. What is this very difficult word to say? Well, it's a data de-identification procedure. Data records are replaced by one or more artificial identifiers called pseudonyms. And the idea behind pseudonyms is that it makes a data record less identifiable without sacrificing data analysis and processing. And so why would you do this? Well, anything worth protecting is worth protecting well. And it provides you some security through obscurity. So you can secure a data set from identification. And it's also kind of required by the law. Not kind of, it is required by the law. I only say kind of because there are these gray areas which I'm not going to get into because I am not a lawyer. So do not ask me legal advice. If you have a question at the end and it smells to me like it's of need of counsel, I will tell you I cannot answer that and that you need a lawyer. A couple more things. As a note, we're not going to get into the mechanics of GDPR. I will reference some articles if it's important and interesting for you to go read. It's actually not that dense of a regulation. So we will be avoiding things like consent, the difference between collectors and data processors, or how it affects your organization. Again, if you ask me those questions, I am not a lawyer, and I will tell you that. But it's important for us to define exactly what it is that we are discussing today, and that is specifically personal data. This is also known as personally identifiable information. The gist is that personal data is any identifiable data, or PII. Note that GDPR refers to it as just personal data. One of the things about the regulation that I don't like so much is that it does paint in very, very broad strokes. So essentially any information that can be used to identify a user, a person, there's this regulation around. So some examples. Basically it's this, is if you can identify someone with it, or it can be used to identify someone with or without a secondary data point, then yes, it's personally identifiable information. If you are unsure, chances are that it's personally identifiable information. So let's talk about data privacy techniques, right? There's two very popular methods. There is pseudonymization and anonymization. Beyond being very difficult to pronounce the first few times that you practice them, they're the two most common approaches to doing data privacy over PII. Pseudonymization we kind of covered a bit already. I want to also point out that according to Article 25 of GDPR, data must be protected by design and by default. So these are important things to consider when you are planning, even in the planning stages of a system. And if you want to understand the requirements underneath the regulation, I recommend you read Articles 25 and 32. I'll note that GDPR only recommends one technique by name, and that is pseudonymization, although they spell it with an S and not a Z. It's something I've learned. Anonymization is a more permanent de-identification procedure. With anonymization, you render the user's data unidentifiable. So maybe one of the reasons why the many teams of lawyers that wrote GDPR's regulations avoided using anonymization is that the mere fact of the operation of anonymizing a data set makes it no longer personal or personally identifiable. So it actually doesn't fall underneath the purview of GDPR, which is something I think is really interesting. If you are struggling to understand the differences, I'll have some examples on pseudonymization, but if you're struggling to understand the differences between the two, I've made this drawing to help articulate the differences between pseudonymization and anonymization. Anonymization is essentially, like, I think of it as an analogy to like Batman's very clever disguise, right? When he puts the mask on, you can't tell it's Bruce Wayne anymore. Thank you. But Superman, not so much. He combs his hair a little bit differently and he puts some glasses on. So at least to all the people in Metropolis that are just not that keen to see that he is the same person, he is pseudonymized. They can't tell it's him. But to us, the readers, there's no anonymization layer going on, right? I really just use this as an excuse to make this incredibly funny slide. I think it worked out. So let's dive deeper into pseudonymization techniques. The one that we will probably go over in this is, the one that we are going to go over is a technique called data masking. And so to mask data, characters in a record are shuffled or substituted in words, maybe substituted or obscured completely. The result is usually a realistic data set that cannot be reverse engineered without the re-identifying information or the algorithm to reverse the masking technique. There are a lot of techniques that fall under this broader category. There's also a method known as approximation, which is instead of saving the user's PII by itself, you approximate it. So one of the common practices this is used for is for date of births. Sometimes you don't want to save a date of birth. You just want to know how old, or maybe the birth month, or maybe the birth year. So then you have a table with those numbers and you increment those once a user subscribes or enters that information in. You don't save that user's date of birth record specifically. Another method, very popular, encryption. And this is something that I expect most people will be familiar with. I do have a question, though. Does anybody know if this is required by GDPR? Yes. No, it is not. Not as a data de-identification procedure. Encryption is required for data at rest and in transit, but it is not the recommended nor a requirement under GDPR for how to de-identify your user data. This is actually kind of interesting because one of the big premises is why I'm doing this talk on pseudonymization is A, it's fun because of the Phil Collins aspect, but two, it's actually better for you as an organization and someone who's serving maybe the role as the data processor and the database administrator. Pseudonymization gives you a lot of value back that you don't necessarily have to jump to encrypting that data set, because this will add compute resource requirements that you don't necessarily need. This is at least my philosophy. Again, I'm not a lawyer, so. And then the final pattern is tokenization, which is very commonly used by companies like PayPal or Apple Pay or Stripe. They will tokenize a credit card information, and then they use that token to retrieve that information when they need it. They only process those data points when they need to. Otherwise, it's saved on either the client side, the vendor side, as this token representation. This is song 2 on the playlist if you're following along. All right. So I'm going to go over a simple implementation example. This is going to set the foundation for how we're going to scale this up in our Django example. So Python already supports a common pattern that allows engineers to replace attributes with a set of methods that can intercept values when they are written and when they are read. Any guesses as to what they are? Not a trick question, but they are either getters and setters of the properties. So for the following examples and for the continuing examples through the Django methods that I'm going to show you all, we're going to use this incredibly simple masking algorithm. The masking algorithm all it does is shift each character one ordinal to the right. And then when it re-identifies them, it shifts them to the left. It does it in a range so that it can not overrun the ordinal ranges for ASCII characters. So it's intelligent from that point, but it's very unintelligent if you use this in production because it's insanely easy to reverse engineer. I'm also not going to talk about algorithms or best practices for doing masking because first, I shouldn't share it with you. 2, this is being recorded. And why would I implicate all of us by sharing an algorithm that then somebody here may go and use, and then that is reverse engineered. Now I am culpable. So it's also, this is a lot easier for everybody usually to understand, and so if I had a more complex or sophisticated masking algorithm, that would take the bulk of time we have for the talk. So to mask and unmask, we're just going to have 2 methods, mask and unmask. And then essentially this is how it would work, right? We're shifting my name, Frank Valcarcel, over every character over 1, and that's what the masked version of it would look like. So an implementation of this, if we're just using a basic user class, we have an underscore name property, an underscore name attribute, and then we have a property method for it called name and a setter on name. And then we just call our mask and unmask methods underneath those 2 functions. And so it'll look something like this now. So when I instantiate user, I'll set the username as my name. If I print username, it's coming from the property, so it'll return my name. But if I'm looking at the underscore name attribute, it's returning the pseudonymized version. This is important to understand because what's being saved in the object and therefore could be serialized later is the pseudonymized version. It wouldn't be my name. My name is only being re-identified in transit. So let's look at a Django example. This is song 3 on the playlist if you're following along. And so we're going to take the same concepts. I'm going to add a few attributes, but we're going to focus in on the name field. Quick question, how many of these attributes are PII? All of them. Yeah. They're all identifiable because together, something like the IP address with one of the other data points makes the user who's saved identifiable. So we're going to move our shifting algorithm, our masking algorithm, into a utils file. The code for this is all available later. I'll share the link with you. And then our mask and unmask methods. Then now here's the user attribute, again focusing in on just the name field. We've done the same process. It's underscore name, and we have a getter and a setter applied to it, which will mask and unmask as that data moves in and out of the objects. So the problem is that we're not done. And for sake of time, I'm going to speed through the rest of this because I want to get to the second example. the model's query set doesn't yet support our properties. You cannot filter, you cannot exclude on the identifiable data values, right? You have to know that Frank will be pseudonymized and masked to Gizbol or something like that, right? And so therefore, that's not a very intuitive way to interact with your data models. The other thing is that pseudonyms are now included in all of our user objects everywhere that we're retrieving them, which pollutes the user model, pollutes the object. It's useless, it's just gonna add weight to that data object and we don't need it. And then also the Django admin has no idea what to do with this. So first, let's start updating the query set. We are going to monkey patch some of the methods on query set so that we can filter and exclude. I'm not going to do all of them. I'm just going to do filter and exclude, and I'll show you that we actually get a few more. There's a bit bang for your buck by just monkey patching these. Also, for sake of time, I won't be looking at the source code, but just to note, the reason why this is here is that when you patch filter or exclude, you get filter, exclude, and get out of the box. So you only have to monkey patch that one function, and you can see this in the source code that they all just call filter or exclude. Then we'll insert our masked values, and we will super the parent instance of our custom models.query set for everything else. So this is what this will look like in code. We have our masked fields, name, and then we iterate over the masks fields and create a keyword argument that we then pass to there's my mouse, our filter or exclude customized method. So now we'll be able to do things like filter on the identifiable name or exclude on the identifiable names. And then the last thing we need to do is override the auth user manager get query set. And you can see how I've done that there for the object. Second thing we have to do is exclude pseudonyms. And pseudonyms are really useless. Like I said, they pollute the models. So there's actually a method called defer. The gist is that if you don't need a particular field, when you fetch the data, you can tell Django not to retrieve them from the database using defer. So it's very similar to the last. We'll create a new list. Hey, F strings for the win. We'll iterate over all the attributes in our model that start with underscore, and then we'll add them to our keyword arguments that we pass to defer, which is chained at the end of our monkey patch, filter, or exclude. And now, when we query using filter, we can use the identifiable information. And then also, the object that is returned does not have those pseudonyms inside of it. I didn't override all. You would have to override all in this method. The last step here is updating the Django admin. So write read is masked and unmasked, but what about Django admin? Well, it doesn't know how to do this. It doesn't know that we want to display the unmasked values in the admin. It doesn't know to mask those values when you submit the forms in the admin. So we have to start by telling it what fields we want to show. Then we'll begin to define a form that we can swap out and place for the default one Django wants to use. You can see we're overriding the built-in user change form from Django contrib auth forms. And we're creating a form with a new char field. On initialization, we get the correct value and check it against the validator for our masked field, which could be important with something like a phone number if you were using phone regex. And when the form's clean method is called, we can get the appropriate value or error out on invalid input. Next, we've got to register this. So we have our base fields of the model, namely username and password, but now we've created a group of subfields called personal data, and we've added the name property to it. And last, we told Django admin how we would like the users to be displayed in the user list. I will note that this last step could be very important, and you may want to, under the regulations of GDPR, you may want to add some logging on this, because according to Article 30, each processor shall maintain a record of all categories of processing activities carried out on behalf of a controller. And a controller can be someone with access to the Django admin, whereas a processor could be you, the engineer who wrote this process, right? You are obligated and responsible for logging every time someone re-identifies this PII, when it happened, who did it, and sometimes why they did it, what that business process was. And so we are set. We have finally encapsulated some pseudonymization through the entire life cycle of this object and how we manage the data of this object. It's stored in the database as its pseudonymized field, and when we retrieve it, it will be the re-identified values. And best, we have access through the Django admin to work with that data as it sits identified, but it's always going to be saved as a pseudonymized field. So the next example is a new and improved method. It's a lot more straightforward than the last one. I show the last one and I build up from it because there's a lot of work that needs to be done on legacy code, and just because the last method was naive doesn't make it wrong. You may have a system that has very few fields that constitute PII, and you need to create some safety and regulation compliance for your clients. That last method isn't bad, it's just that there are better ones if you are starting from the ground up. If you're following along, this is song 7. So we are going to do data masking via custom fields. Using a custom field class, we will automatically mask values on their way in and out of the database. With this approach, we no longer require getters and setters, the custom query set and corresponding user manager, or the bulk of changes we did to the user admin because we were doing at the field level. So we're taking the same user model as before, and here's our customized field. It's called Pseudonymized field. The class constructor and deconstructor methods will accept a field type. So we need to tell it what kind of field we are saving underneath. This will set the appropriate database column. And our deconstruct method has to mirror any argument changes we make in the constructor. This is the only thing I don't like about this method. We will also override the get internal type, which specifies the internal type of the field. I'm sorry, I'm trying to show it to you guys. If you've seen the field, the source code for field, this will look familiar. We are essentially overriding some of it to provide a masking and unmasking method where that data goes in and comes out of the database. And all of that work is done by these two methods. GetPrepValue is called prior to interacting with the database, and then from DB value is called when a value is pulled from the database. So this is the core of this implementation. This is what makes it sing. We'll use GetPrepValue as an opportunity to mask values before they are saved, and we'll mask values for query purposes, which is just really cool. Also, we'll unmask our values when they're pulled from the DB and before they're converted to a Python object using DB value. And so this is what it would look like when we apply it to our user model. We have a field now for name of pseudonymized field, and we tell it what type of field it will be, like what the field is underneath the hood. There's a tuple here that accepts the masking and the unmasking algorithm. So these are not tied to the customized field. You can swap these out. You can use different ones for different field types. In fact, that may be one of the ways to improve upon this, is to have something underneath that knows intuitively how to shift something like a phone number, or something like a zip code, or something like a name or a date of birth. And you can see that there's still validations that can happen on the phone field. And that's it, y'all. So thank you. I am going to take questions. There's some sample code and a blog post associated to this, and you can find them at those links.
I see you have sample code, but have you packaged up this pseudonymized field on PyPI so it can be used by other people?
I wanted to. So I shouldn't say I. We wanted to. This was a collective effort with a number of engineers at Cuddlesoft. We've chosen not to, mostly because the pseudonymized field code isn't that verbose, and we don't see the value in having something like that easily injectable and or available for your code. You can just copy and paste it. We also think that there's a number of ways to improve upon it, which we haven't gotten around to yet. But it's just not, I don't know. To me, it's not significant enough of source code that we need to have a package for it.
Hi, thanks for the talk. Can you explain why you wouldn't use encryption as a pseudonymization method instead of kind of rolling your own pretty much?
There's a lot of reasons to use it. So it just depends on the use case. I think pseudonymization doesn't require encryption as its masking, unmasking method. I think you can achieve a lot with a clever sorting or shifting algorithm that you control, or that maybe even you seed somehow, right? Encrypting and de-encrypting the object's attributes adds a lot of compute resources, or adds the requirement of needing a lot of compute resources. And so sometimes I just don't think it's necessary to add that type of overhead when there are perfectly, there are methods that exist that will perfectly handle the regulatory compliance of it. The other reason is that think about it from a database administrator's perspective. sometimes you encrypt something and it fills out a lot more space than, like a phone number would. Whereas like if you are saving a phone number that's just shifted around using some unique method, the database space and therefore the representation of that data in the database looks a lot more like the identified data, right? Versus some, long hash.
Hi, I was just trying to figure out how to phrase this question. So this is a really useful example of how to adhere to GDPR. I guess that the broader question is if this is a useful way to make data more anonymized, irrespective of GDPR criteria. Do you have general advice for like people building whole apps to be more anonymizable? For their,
Pseudio.
Yeah, for their users. Yeah.
Yeah, we use this method to achieve HIPAA compliance. And there's no, just because there's a regulation telling you should do this doesn't mean that you shouldn't do it if you don't have to adhere to said regulation. Like I said it in one of the earlier slides, like anything worth protecting is worth protecting well. And I think as engineers, our responsibility over time has increased in like how we need to handle users' data. Especially, so I'm a consultant, and especially for folks that are consulting for other entities, right? Like if your client doesn't appreciate having some kind of data privacy technique in place to secure users' data, there's no reason why you shouldn't have that, right? I don't necessarily think this method adds a lot of complexity over top of what you're trying to achieve. And then at the end of the day, that client could go on 3 years and have somebody working on the project that doesn't know how to configure an S3 bucket for the database backups, but you did all of their users a solid by just implementing some kind of pseudonymization technique, right?
Yeah, so my question is, what is like the specific threat model that this tries to achieve? Because if your database was dumped, a computer could easily reverse engineer a lot of these because it's not encryption. So I guess the question is, what's the threat model that this actually solves?
That's a really good question. And if we're just talking about database dumps, I disagree. I think it could take a long time to decrypt this if you have a smart masking algorithm. This one's not smart. This one's don't use this. But there's a lot of pseudonymization techniques that avoid shifting as like the primary basis for moving around that data, or sorry, de-identifying that data, and you can mix and match. So tokenizing is not encryption, but yet nobody can reverse engineer a token to get back the valid credit card information to steal those credit card numbers, right? So I just presented masking and the shifting algorithm as a way for us to all easily understand like what was going on with the data in transit.
What do you guys do for, I know we had a large health provider, and logging of the audit trails once they're anonymized.
Yeah, that's a really good question.
Sorry, you don't need to answer it.
No,
Frank will be available in the hallway.
that is a really good question. The challenge is that it's always really specific to like what the use case is. So like something in the Django admin, like creating a log for that, would solve that problem. On accessing data between systems, we like CloudWatch. And then because we can use IAM to create the roles that we need, and we can track which roles are accessing the data from which services. And then also IAM and CloudWatch give you a ton of like transparency into just access of systems or access of services and things like that. And you can control when user passwords need to be reset. You can enforce multi-factor, a lot of cool stuff.
Okay, so let's thank Frank one more time for the talk and the nostalgia.